This is the second part of lesson 9.5. So in the last video, just got done talking about circular objects. And so when we're talking about something where the order doesn't matter, so like it's just a group of things, and so actually there should be like a little dividing part. When we're talking about groups of things where order doesn't matter, like let's say you're putting all the toppings on a pizza, that actually doesn't matter what order you put on. At least technically it doesn't. And so this is a combination, and so it's where order doesn't matter. And so if you think about a couple of examples, a pizza is an example where it doesn't matter. If you're going to just choose 3 people to go with you to get ice cream, it doesn't matter what order you choose them in. If you are doing something like a lock, like the kind that you have on your locker, it's called a combination lock, but it's actually a permutation lock, because if your combination is 3, 14, 12, it matters what order you put the numbers in. And so a combination lock is actually a permutation because the order does matter. So when the order doesn't matter, it's called a combination. So that's what we're going to talk about next. So first of all, to distinguish between a combination and a permutation. So example 10, if you choose 3 students to get an A from a class, does it matter which one you choose first, second, or third? If they're all going to get the same thing, then it doesn't matter. So this one would be a combination. Example 11, choose a committee of 5 people from the school. So again, does order matter? If you're just going to choose 5 people to represent the school, then it doesn't matter what order they're in. So that would also be a combination. If you choose a president, vice president, and secretary, does order matter? Well, each of those positions is different. And so if you choose the first person to be president, second to be vice president, and so on, it does matter what order you choose them in. And so for this one, this would be a permutation because the order does matter. So as you're deciding what to do with each of these problems, you have to decide, is it a permutation or a combination? And before you can do any calculations, you have to decide that first. How you do combinations mathematically is different than permutations because you have to take into account that we don't want to double count things if the order doesn't matter. Like if we say a ham and pepperoni pizza, that's exactly the same pizza as if you say pepperoni and ham pizza, exactly the same thing. So the way that you do combinations, so in objects taken R at a time, you see that the formula is very similar to when we did permutations, because this part was the permutations. What this is, you'll recognize it from the circular objects or the arrangements of the words in Mississippi. That's taking away the different duplicates that we have. So eliminating the duplicates is what the combinations formula does. So for example, how many ways can you choose 2 books if there are 10 books on the shelf? So if you choose a book first and then you choose it second, it doesn't matter which one you chose first or second. So you're taking 10 objects and you're choosing them or doing a combination of them, 2 objects at a time. So the way that you do the math on that is you say 10 factorial over 2 factorial and then 10 minus 2 factorial. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the 10 times 2 factorial, that's 8 factorial. So that's this one. So I usually make sure that that gets put right underneath so I can cancel it. And then the 2 factorial is just 2 times 1. So when I cancel 8 factorial, and then the 2 times 1 can cancel with a 10 and make a 5. So 5 times 9 is 45. You'll see that these numbers are a lot smaller than if we did permutations because we're taking out all the duplicates. So if you pick a science and a math book off the shelf, it doesn't matter which one you chose first. So we're taking out, instead of saying that that's 2 things you could do, that's only 1 thing you could do. So let's try another one. So if we're at the store and there are 20 candy bars on display and your mom says that you can have 4 different candy bars. So how many ways can you choose these 4? And so it doesn't matter if you get the Snickers or the Twix first, you're getting both of them. So you're going to take 20, and it's a combination because the order does not matter, and you're going to pick 4 of them. And so you're going to do that math. And so I would use the calculator on this just because the number is so big, 20 times 19 times 18 and so on. And so again, to put that in your calculator, you're going to type in 20, go to the math menu, go to the probability menu, choose NCR, and then you're going to type in 4. And that number, if you do that right, it should give you 4,845. Now, just to show you, if we would have done 20p4, and so we said a Snickers and then a Twix is different than a Twix then a Snickers, you're going to see you're going to get a lot more combinations there. So a lot of ways that you could do that besides. So it's not a permutation because the order does not matter. Okay, number 15, there are 38 students in class. I'm going to choose 6 students to get a 0 next time. So does order matter? So if I'm choosing 6 and they're all getting a 0, it doesn't matter who I choose first. So I just choose 6. So we could say 38 and a combination, and we're going to choose 6 of them. So how many ways could I choose 6 students to make that happen? And so there's 2,760,681. Later on, we'll use combinations and permutations to find some probabilities. This one's a little bit harder, but we're going to do some other problems where we have to find some probabilities. So let's do example 16. I'm going to choose 1 student to get an A, 1 to get a B, 1 to get a C, 1 to get a D, and 1 to get an F. So I'm choosing 5 students out of the 38. Does order matter? Well, it matters if you're the one chosen to get an A or if you're the one chosen to get a C. So yeah, order does matter here. So we're going to do the same thing where we do 38 and we're going to pick 5, but we're going to do it with permutations because order matters. So put that in your calculator. Again, just because the numbers are so big, I don't expect you to do this without a calculator. And so put it in your calculator, see if you get the same thing I do. Okay, so over 60 million ways for me to choose out of 38 students how I'm going to award those grades. Okay, example 17. Jolie is answering a fill-in-the-blank section on an exam. There are 6 answer choices, A, B, C, D, E, and F, and 5 blanks to fill in. Each answer choice can be used only once, and one answer will not be chosen. So this is kind of like a matching thing where you have more choices than you have possible answers, and so you have to choose which ones. So how many different ways can she fill in the 5 blanks? So if you think about it, we've got 5 blanks. And how many ways could she fill in blank number 1? Well, she could choose A, B, C, D, E, or F. So there's 6 ways that she could do that. Now, since she's already chosen, let's just say she chooses A for the first one. Since she's already chosen that one, now she only has 5 possibilities. And then 4, and then 3, and then 2. And so when you multiply all that together, again, that's that fundamental counting principle we talked about earlier. When you multiply all that together, there's 720 ways that she could get that. Now, we could also do exactly the same math if we did 6P5, because the order that you give the answers, if you do A, B, C, D, E, that's going to be a different set of answers than if you do B, C, D, E, F. And so you could get exactly the same math if you did 6P5. That's exactly the same thing. Okay, example number 18. A bakery sells cupcakes, pastries, and donuts. You are ordering for a group. You have 8 different cupcakes that you could choose. You have 6 types of pastries and 12 types of donuts. So in how many ways can the following items be chosen? So we're going to choose 4 cupcakes, 2 pastries, and 4 donuts. So we're going to get 10 things all together. So is this a permutation or a combination? So if you get a sprinkled donut versus a chocolate donut, does it matter which one you pick first? The answer to that question is it does not matter. And so we're going to be using combinations for this. Now, if we're going to make one choice, we're going to figure out how many ways we can make that choice. Then that's the cupcakes, and we're going to do the pastries, and we're going to do the donuts. So what do we do to find the combination of all of them? This is where you're going to multiply them together. It's kind of like back to the test question. You multiply all of the ways that you could choose the first answer, all the ways you could choose the second answer, and so on. So we're going to do that. So to choose the 4 cupcakes, we have 8 cupcakes, and we're going to choose with combinations 4 of them. And then we're going to have 6 types of pastries. We're going to pick 2. And we have 12 donuts, and we are going to pick 4. So use your button on your calculator and type this all in. So if you do all of this correctly, you can do it all in one step on your calculator. You should have 8 NCR4 times 6 NCR2 times 12 NCR4. And when you do that, so pause this and make sure you can get that on your calculator. when you get that, you'll find that there are 519,750 ways you can walk out of that store and make those 10 choices. So that's a lot of ways that you can choose. Okay, the last question is about a TV reality show. And so it's going to randomly select a team of 3 individuals from the group of 9 for a particular competition. So this is kind of from my favorite show, Survivor. And so if you're going to have a competition and you're going to select 3 people to compete in this. So here's our 9 individuals. And just to make it easy, I made them A, B, C, D, E, F, G, H, and I. So that will make it easier to write things down. But anyway, so we're going to pick 3. Now, if you're just going to have a group of 3, it doesn't matter which one you choose first, second, and third. There's no distinction in their jobs in this competition, so it doesn't matter. So we're going to be using combinations here. And so that's important to make sure that you know at the beginning of the problem, because that's going to make a huge difference. So the first question says, find the probability. So I'm not finding out how many ways can they do something, but what's the probability that your team includes David, Emily, and Fran? And so if I want a team with those 3 people on it, how many ways can I get that? Well, there's only 3 ways. It can go David, Emily, Fran, Fran, Emily, David, or Emily, David, Fran, I don't know. So there's only 3 people that we're going to choose from. So basically, I'm going to have 3 people that I want to choose from, and I'm going to choose 3 of them. So when you do that on your calculator, what do you get? Or if you didn't do it on your calculator and you did using the formula, what do you get? So you want to put that in your calculator just to make sure, because it's kind of a funny one. But when you do 3 people and you choose 3 of them, there's really only one way that can happen. So we've got 1 for how many ways can I have a team that looks like that. Now, how many ways can I choose a team, period? So if I have 9 people and I'm going to pick a team of 3, how many ways can I choose a team? And so do that possibility. So I'm going to have 84. So what's the probability that my team is David, Emily, and Fran? Well, that's 1 out of 84. That's my probability. So we can say 3C3 over 9C3, and that comes out to be about 0.0119. It's not a very good chance that that's what my team is going to look like if you're just randomly selecting. You might get 1 or 2 of those people, but it's a pretty unlikely situation where you get all 3 of those. Okay, the second part of it says find the probability that the 3-member team includes Bob and Carlos. So we don't really care who the third person is, but we want those 2. So you're going to have, basically, you're going to pick Bob and Carlos to look at like what you want to have happen. So the first 2 spaces are already filled. And so how many people do you have left to choose from on that last position? So you've got 7 people still that haven't been chosen. So you've got 7, and you're going to pick 1 of them. Now, if you're only choosing 1, it doesn't matter if you do combinations or permutations. It's going to be the same thing. So basically, you've got 7 ways that you can fill that last position. Now, again, how many ways can you choose a team? And it's going to be the 9C3. And so you're going to have 7 out of 84, which is 1 out of 12. And that's about 0.083 repeating. And so just to make sure you understand, like Bob and Carlos, like that's not a choice. They're going to get 2 of the positions in order for my desired outcome to happen. So the only question is who's going to be in that 3rd position. Okay, if we go to the 3rd question, find the probability that Ginger is on the 3-member team. So again, kind of like the Bob and Carlos thing, we've got 1 position, it's going to be filled with Ginger. So how many ways can I fill the other 2 positions? So you think, well, there's 8 people to choose from there and 7 people to choose from there, and so you get 56. But let's just say, for example, what if you choose Ann and Bob? Isn't that the same choice as if you choose Bob and Ann? So there's that whole duplicate thing you have to worry about. And so really it's probably an easier thing to say that we're going to have 8 people and we're going to choose 2 of them. And if you use the combinations, that gets rid of your duplicates, and so it comes out to be 28 because it's 56 divided by 2 because there's the 2 duplicate teams. So 28 ways that Ginger can be on the team. So if the question was just how many ways can Ginger be on a 3-person team, there's 28 ways that can happen because Ginger is one of the picks then. The question, though, is find the probability. So if you get all the possible teams, that's 9C3, and the probability that she's on it is 28 out of that. So 28 out of 84. And so that's about, actually it comes out to be equal to 1/3. And so that's a much better chance that Ginger is just going to be on the team. Now, if she gets on a specific 3-person team, that's different. But just the probability that, if you're Ginger, what's the probability that you're going to get chosen? You basically have a 1 out of 3 chance. What's the probability that David and Henry are the last 2 picked? Okay, so what we're looking at here is we're looking at first choice, second choice, third choice. Now remember that when we're doing the probability, our desired outcomes are what we're looking at. So for my first outcome, like how many people are going to get that first position, I don't want it to be David or Henry. It can be anybody else. So I've got a 7 out of 9 chance that it's going to be anybody except for David and Henry. So one of them is gone now, so I have 8 people left. How many ways can I fill that second position? Well, the second choice has to be either David or Henry. And then the last choice has to be whichever one wasn't chosen out of David and Henry. That actually should be 1 out of 7. Okay, so this is your first choice. That one's open. Anybody can get in the first and second position. But second and third place, the last 2 picked, we want for our desired outcomes here to be David and Henry. So you multiply all that together, you get 7 times 2 times 1, and 9 times 8 times 7. That's 504. You reduce the fraction, it comes out to 1 over 36. And so the probability is about 0.027 repeating. So about almost 3% that's going to happen. So not a high likelihood that that's going to happen. But that's how you would use combinations with the probability. And so that's just some examples. You'll have some other opportunities to work on something like that. Okay, and then the last little box in your notes is just some FYI, just showing you some differences. And so what if you have 8 and you choose 8? We did this one earlier with the 3 and we're choosing 3. We did that one. And so when you do that, 8 factorial divided by 8 factorial, okay, that's just 1. And 8 minus 8 is 0. So 0 factorial, this is kind of one that comes down to definition. And so go ahead and try that on your calculator and see what it gives you. But 0 factorial, it just means that you're not multiplying anything at all, and there's just one way to do that. So 0 factorial is equal to 1. That's kind of just a definition that you need to know. And so you've got 1 over 1, which is 1. Okay, what if you have 8 and you choose 0 of them in combination? So how many ways is there to choose no people? Well, again, there's just one way. You're going to have 8 factorial over 1 over 8 factorial. And so you're going to have 1 over 1, which is 1. What if you're doing 8 and you're going to choose 1 in combination? So combination of one person, but you have 8 to choose from. So you've got 8 factorial over 1 factorial over 7 factorial. So the 7 factorial with the 8 factorial, you're just going to be left over with 8. There's 8 ways to make that happen. And then with 8 factorial over, well, the 8, and you're going to choose 7 of them, how many ways is there to make that happen? So if you write this out, 8 factorial over 7 factorial, actually I'll write 8 times 7 factorial on top. And then 8 minus 7 is 1 factorial. So we've got this, and so it's just 8. And so those are just a couple of special situations that you need to make sure that you're aware of. And this is kind of where you need to really understand, like, what's the difference between combinations and permutations and be able to distinguish those differences. Again, 0 factorial is 1. That's an important one to know. If you're not allowed to use your calculator, you need to be able to figure all of these out. So make sure that you know those definitions.